Right, so the way to solve this is we need to solve it in a certain sequence. Okay, so the sequence goes. Welcome to MirrorMatics. Okay, today we'll be learning about transition matrix. Right, so let's do a recap. How transition matrix works is that if for this instance, okay, you're given a scenario. Okay, the scenario states that if it is dry today, okay, the probability that it will be dry tomorrow is 0.6, but the probability that it will be wet tomorrow will be 0.4. Okay, but the scenario changes when it is wet today. If it's wet today, then the probability that it's dry tomorrow is 0.5, different from the other one. Okay, and the probability that it's wet tomorrow again, given that it's wet today, is 0.5. Okay, so different starting point gives a different probability for the next day. Right? So you create this transition matrix whereby the one at the top is the current state and the one at the side is the future state. Right? Okay, so as you can see, for instance, if I say today is dry, tomorrow is dry, 0.6, that's this branch. Okay, if today is wet, tomorrow is dry, is this branch. Okay, wet and dry, 0.5. Okay, so having understand that, okay, the magic comes when we actually calculate t squared. Okay, so if you use the matrix calculator, t square is given as this answer: 0.56, 0.44, 0.55, and 0.45. But what do these numbers mean? Right? Okay, to understand that, let's try to go back to matrix multiplication but manually. So how we do manually is that we take, for instance, if I want to get this 0.56 over here, okay, what I must do is I must take 0.6 times with 0.6. Okay, add that with 0.5 times 0.5. Okay, let me double stroke that. Okay, so but the thing is 0.6 times 0.6, when we look at this tree diagram, it's actually this branch at the bottom. Okay, so you will end up here. Start here, we end up here. That's 0.6 times 0.6. And then we're going to add that with 0.5 times 0.4. And that is actually this branch. It's just that this branch is taken as 0.4 times 0.5, a bit opposite. But multiplication is commutative, so it doesn't matter which one comes first. So it's actually this branch where we end up at D again. Right? So when we add these two, the meaning contextually is the probability that it is dry today. Okay. The probability that it is dry in 2 days time, given that it is dry today. Right? Okay, so this particular answer, because remember we said that here is the current state and here is the future state, but future state of 2 days. When we look at t alone, it's future state of tomorrow, but when we look at t squared, is the future state of the day after tomorrow. Okay, and if you calculate the rest, it works the same way. So therefore, T3 will be the transition matrix of the future state of 3 days time, T4 4 days time, T5 5 days time, so on and so forth. Right? Okay, so that's the significance of T squared. Right? Mirror Cikgu Hadi, that is how we study.